Figures 1217 through 1221, commission employee, base plus commission employee hierarchy with private data. So in this example, we're going back and changing our commission employee class again. And once again, we're going to go back to having private data because in general, not always, but in general, when you define a class, you want all of the data to be private so that you as the designer of that class and implementer of that class have complete control over that data and how it gets used. The other thing is if you allow other classes to directly access your data and you need to change that data, that makes the code brittle because every class that directly relied on that data will have to be re-implemented accordingly. So by encapsulating that data as private members in the base class, we are actually helping to protect the derived classes from changes to the base class's data. As long as the base class's public interface remains the same, the derived class can still inherit from the base class and use it the same way without knowing what the details are of the private data. So we are going back to private data here. And as I had mentioned in several previous videos, one of the goals in this example is to use the best possible software engineering. So given that, we've made some changes in the commission employee class's implementation as well. Let's start here by looking at the constructor for the class, where you see we're now using a member initializer list. And in particular, we're initializing the first name, last name, and social security number string objects in the member initializer list. Now, this is actually a good programming practice in general. Every object and every piece of data that you can initialize in the member initializer list, you generally should. Unfortunately, you can't call member functions here like set gross sales and set commission rate, which is why we're doing those in the body of this constructor so that we can make sure that those pieces of data get validated. Now there's another reason why it's a good idea to use the member initializer list syntax to initialize the composed string objects in this case. And the issue is that whether you want to or not, the constructors for these string objects are going to get called even if you don't provide the member initializer list here at line 12. And so we would actually wind up with double initialization. So what would happen, in fact, let's go just open up a previous version of the commission employee class. It's not showing up there, so I'll do it this way. So I'm going to go back to the previous version of the commission employee classes constructor so that you can see the old way that we did it. So what's happening in the old constructor here is before we get to line 12, every member object has already been constructed, which means that we're calling the default constructor for the three strings and initializing them to the empty string. Then separately, we are assigning a string to first name, assigning a string to last name, and assigning a social security number string to social security number. So what in effect we're doing is then replacing the value that was already used to initialize these string objects with additional string contents. And that's a little bit more overhead in our program. If you can initialize a member object in the member initializer list, then it's always better to do that because that way you eliminate this kind of extra overhead of the additional assignment that could have been done just via a constructor call and passing data, which is what we're doing here on line 12. So this calls the first name strings constructor, passing it first, last name strings constructor, passing it last, and social security number strings constructor, passing it SSN. And by the way, I should mention that the order in which these constructor calls will happen is the order in which these pieces of data are declared in your class. So it's always going to be first name, last name, and social security number in that order, regardless of the order that you list the member initializers here in line 12. So in this constructor, we initialize the objects via the member initializer, then we initialize the sales and commission rate. Now, the set and get member functions are still the same for all the different pieces of data. We have changed, however, the earnings member function to call get commission rate and get gross sales rather than accessing commission rate and gross sales private data directly. And as we've mentioned in earlier lessons, it's generally a good practice even within your own class definition to call your get and set member functions to access and manipulate your private data. And what that does is it helps protect you against future changes that you may need to implement in the class. So for example, if you have to rename a piece of data, if you access that piece of data via a get method, member function, and a set member function, then you only need to change the bodies of those two member functions, and every place else in your class where you were previously using those member functions can stay as is. You don't have to re-implement those other member functions. So it's just a good way to enhance the software engineering, reusability, modifiability, and maintainability of your class. And we did the same thing here in the print member function with calling the get member functions for the first name, last name, etc. So that we could output the data. So those were the changes to the commission employee class in this example. For the base plus commission employee header file, it's identical to the last example. We're still publicly inheriting from class commission employee, but now class commission employee has private data once again. So in the base plus commission employee implementation file, because the base class has private data again, we've modified how we're accessing the inherited private data. And so let's take a look at the implementation of class base plus commission employee. Here we have the constructor, and remember the derived class constructor is required to implicitly or explicitly call the base class constructor. Now you can only have an implicit base class constructor call if the base class provides a so-called default constructor that can be called with no arguments. If the base class constructor requires arguments, which is the case for class commission employee, you must call it in the member initializer list, otherwise you'll get a compilation error. So in fact, if we comment this out and we go and try to build this solution, you'll see here that we have an error message that says there's no appropriate default constructor available in class commission employee, and that error message is happening in base plus commission employee.cpp at line 15. And if I go back to my source code, it thinks that it's preceding basically the left curly brace of the member function's body. So if we get rid of that, then that error message will go away. So first, when a base plus commission employee object gets created, the memory for the entire object, all 6 pieces of data, gets allocated. Then the constructor for the base class gets called and initializes the first 5 pieces of data, which were the inherited pieces. Then, once that's done, the set base salary member function gets called to initialize the 6th piece of data. Set base salary and get base salary are the same. Now let's take a look at our earnings member function, and you may recall, in fact, let's go look at commission employee. Here's the commission employee's earnings function, which is already calculating commission rate times gross sales. So rather than re-implement that from scratch here in base plus commission employee, we're actually implementing the base plus commission employee's earnings method in terms of the commission employee's earnings method. Remember when we first started talking about inheritance, I mentioned the fact that our base plus commission employee class actually has 2 earnings member functions or methods. It's got the one that was inherited from class commission employee and the earnings member function that's defined in class base plus commission employee. So what we're saying here is get the base salary for the base plus commission employee and add to it the result of calling the commission employee class's version of the earnings member function, which already calculates gross sales times commission rate. So rather than re-implement the member function from scratch that we're redefining from the base class, we use the base class's version as part of implementing the derived class's version, and this is a very common technique when you are creating a derived class to reuse portions of the base class even when you're redefining a particular member function so that it's customized for your new class definition. And notice, by the way, that we have the scope resolution operator and the base class name in front of the earnings member function call. If I were to remove that, then I have infinite recursion here, because when I just say earnings by itself, it's going to think it's the base plus commission employee class's earnings member function, which would result in another call to the function that starts at line 32 and again and again and again until we blow the function call stack in that case. So again, it's important when you're calling a base class member function that has the same name as your derived classes as one of your derived classes member functions to use the class name and the scope resolution operator to resolve precisely which one you want to call. Now, from another member function, if I call earnings, inside of this class, it's going to call the base plus commission employees version. I would always, within class base plus commission employee, have to write a call to earnings as shown on line 34 if I want to call the base class original version of the function. And then finally, the print function looks a bit different now. If you remember, the original print function in class commission employee already outputs the words commission employee and all of the data that is associated with a commission employee. So rather than rebuild all of this in the new derived class, I'm going to output first base salaried in front of this, and after everything else, I'm going to output the base salary. So take a look at how we did that. We start by outputting the words base salaried. Then we call the commission employee's version of print to output the data as was originally defined in class commission employee. Then we output the base salary information after that. And then finally, in this example, we have once again the exact same main function to test class base plus commission employee. And if I go ahead and run this example, you'll see after it builds and executes that the output of the example once again is identical to the two previous working versions of the base plus commission employee class, once again showing you that we were able to inherit and use the capabilities of class commission employee. The key difference in this example is that we've now gone for the best possible software engineering, and within the implementations of our two different classes, we've made sure that anytime we need to modify or access a piece of private data of a given class, that we use the get and set member functions to do that. We've also, in the base plus commission employee class, re-implemented earnings and print in terms of their counterparts from class commission employee. And all of the techniques that we've shown you in this example will be applied going forward into the next lesson as we start to introduce the concepts of polymorphism as well. Now, we have one last example in this lesson, which is going to show you the order in which constructors and destructors get called in an inheritance hierarchy.